Can you ask others to join, or let's have another 1 or 2 minutes, right? Are you back? Okay, let's start it. So actually, what we're talking about is why big data is hard when we are dealing with the searching and the processing. And because of this that problem, we have a solution called distributed processing, and we talk about the partition data across multiple machines, then processing parallels, right? So each machine run the same logic on its local channel simultaneously. Then finally is a map reduce on the combined results, right? So collect partial results from all machines and merge them into a final answer. Okay, then other thing is actually the hard handle failures automatically, right? So Apache's MapReduce and the Apache Spark do the same thing. So it handle these steps automatically. Okay, so we need to only to write logic for a one processing of a one record, and the what framework will do it. It will scale it and run across the thousands of machines. Okay, so then let's move to the other side. It is complexity, right? So when we are talking about the complexity, so first, big data systems are not built on actually single computer. Okay, so instead of that, they use many computers that's working together. So this is called distributed system actually. So then while this help us to handle large data, so when we have more machine, it helps to large data. But the thing is, it's make things more complicated. Okay, so because of all these machines need to be communicated and stay synchronized. Okay, that's the um, thing that we need to deal with. So system built from many computers, just one, not just one, right? So then the second is the volume of data extremely large. Okay, so simply one machine cannot store process it. So we need to split the data and distribute it across the multiple machines. So, but then managing is the where that data is stored and how to access it quickly becomes a challenge, right? So that's a one another point of complexity. So the other point is third one is we are not just storing the data, right? So we are also running complex analytical and complex machine learning algorithms, right? So doing this time at a kind of a small level easy, but think about if we are dealing with the thousands of machines, or maybe millions of data points, right? It requires the powerful system, and we need to carefully design, right? Another important point is that big data systems are cutting of technology, right? Cutting edge of technology means they're combining ideas from distributed system and databases, right? That means they are still involved in and can be a difficult to design and maintain. Okay, that's why we need to kind of at the frontier distributed system and database research, right? So more data doesn't mean it's simply models, right? Often requires more sophisticated algorithms. Okay, so the reason is so also having in fact of often requires more advanced and sophisticated algorithms. We need those things to get useful insights of that data. Okay, so finally it's when you use many machine, as I said earlier also, failure is a common thing. So some machine may crash or lose connection, right? So we must design the system with fault tolerance. Okay, so that means the system should continue working if even some parties fail. Okay, that's known as fault tolerance. So in here, in this slide, as a summary, we can get big data is very hard because of the distributed system, massive data size, and complex processing and advanced technology, and need to be handled kind of fairly effectively. So, okay, the reason we need tool is okay. So imagine that you are going to build a distribute processing system, right, from the sketch, right? So before um, writing a single line of analysis logic, you need to solve what kind of, let's say, network communication protocols, right? You need to solve it, right? So how do machines send data instruction to each other, right? So we are, I told you that it's combining of machines, right? Then serialization, right? I mean convert the memory in memory data into a kind of a byte and then travel across the net, right? So the other point is kind of fault detections. Okay, so how does the cluster know the machine has failed or temporary, so right? So that's called fault detection, right? So then other one is uh, you know, cluster initialization, right? Kind of a point there, cluster initialization and management, right? So how do you bootstrap 500 machines so they know each other, right? And each other to collaborate, right? So that's kind of a cluster initialization point, right? So that means without tools, we need to do this, right? The other one is progress in monitoring. Okay, so how do you know how far job getter fast is and which tasks are slow and kind of stuff we need to make it kind of a monitoring stuff. Okay, so actually solving these kind of problems before you doing a kind of a actual analysis is completely kind of an impractical scenario. Okay, that's why we get the tools. Okay, it's a kind of an abstraction one. So big data tools like MapReduce and Spark, it solve these problems at once. Okay, then you give a kind of a simple program on the top, and then it will write kind of two function, right? Map and reduce. And I think, did you search the what is map reduce, and based on the example I provided you, did you search on the chat GPT? Can anyone answer? Hello, can you hear me? Yeah. I think, did you search what is map reduce and in the chat GPT, and ask AI to explaining using the word count example? Did you search it? Hello.
Yes, sir. Search it.
Okay. So that's so this is kind of a thing, right? So I need to learn by yourself as well, right? So here's the thing, right? So okay, so let's think about like this, right? I have a sentence. Okay, so cat, dog, cat. Okay, simple example. Okay, cat, dog, cat. And for that sentence, how many words for cat? It's two cat and one dog. Okay, so manually. Okay, so when we look at that sentences, we can tell it, right? So if you see a kind of a sentence, a cat dot cat, and somebody tells you to count that each word, you definitely you say two times cat and one time dog. Okay, that's pretty much easy. But think about that you have 10 TB of web pages, and it's huge, right? So then, and you need to count how many times that each word appears. Okay, so it's kind of an impossible one to do, is kind of a manually. Okay, so in that case, in the big data, you can do use this one using map reduce. Okay, so in the next lectures I will go deeply, but as I said earlier in this lecture, I need to have a sound knowledge what's we are going to learn. Okay, so okay, let's move to the first one, right? So first one is map. Map means split and tagging, right? So basically the output of the map is kind of uh, key value stuff. Okay, so for example, for the sentence cat dog cat, so key is cat, uh, value is 1, right? So what happened inside the map is we are writing a kind of a code. If you see that word once, put a tag. That means just think about arrays of word, arrays of sentences, right? For each array of sentences, for each word in that sentences, you need to create key value pair. What's the word and what's the value? Okay, so it's a simple logic that's called mapping, right? So the other one is reducing. Reduce means group the same word and add it. Okay, group means we are group the same word. For example, we are grouping the cat word. So then how many cat word? One plus one, it's into two. And how many dog words? It's one only. So it's a kind of a simple logic, right? So you don't need to handle that kind of a hard disk stuff. For example, I say that 10 terabytes of web pages, something like that. You need to don't you don't need to handle that kind of a hard disk stuff, right? The system will do is split. What system will do is actually it splits 10 terabyte of data across kind of, let's say, 1,000 machines or 500 machines, right? Run our load, run our code parallelly. Then that means mapping part, it will run it at each machine, right? Then group the word automatically. That's the reducing part. And then finally it's grab into together and give me the output answer, right? So as well as other than that, it handle the failure machines and kind of stuff, it will quickly just do it, right? You see, if we have a kind of a, let's say, 10 terabyte of data size file, and we need to do at a kind of a one machine, uh, you can imagine how much time that costs for the final output, right? Instead of map and reducing, right? Map and reducing means we are writing a separate code for map, then parallel run it parallelly. That means we are count each word in the sentence and tag it. That's the mapping part. Then for the reducing part, we are grouping that words and count it. Okay, that's what we are dealing with the map and reduce, right? So in this framework, kind of a, I am saying that the Apache map and reduce, it's the framework is kind of, very powerful, right? Because you don't need to manage servers, then handle failures, then process hit data manually. So that's kind of a deal you don't know to do it, right? So with the write of kind of 10, 15 line of codes, then system do everything else. Okay, that's a reason for why we need tools. Okay, so this is the map reduce part, and these are the things that I explain with a kind of you know examples, right? Now let's move to the value propositions of big data. Okay, so that means value proposition is it's a kind of example scenarios that we how it values for our day-to-day life. So big data infrastructure is valuable because it's enabled, right? So if we go each and every category in here, the customers, social medias, employees, supplies, and sites and developments, you can see how it valuable, right? So for example, customers, you can see its chain predictions, right? So for example, let's say uh, kind of get a kind of a a telecommunication company like Dialog Mobile. So it can you know identify the customers who are supposed to pay the bill within 30 days, right? Kind of stuff, right? So then customer service. Okay, so analyzing all support call transcripts and identify top 10 complaint reasons, right? And fixing those 10 issues and then kind of stuff, right? So then other thing is for the employees kind of stuff, decision support, right? So the real-time dashboard showing operation stuff to the higher management to take decisions in a kind of the post systems I told you earlier. So then fraud detections, right? So machine learning models can train billions of historical transaction and identify the fraud employment who explains claim kind of an inaccuracy way. So using the machine learning models, right? So then the supply chain and stuff, and then the other thing is actually uh, um, yeah, so these are the smart spaces for site and deployments and supplies, and this is a kind of a value proposition figure that I need to tell you for get the idea. So how it value for each and every sectors, right? So then there are some use cases I added for you as well. The weather forecasting use case, right? So it's a kind of a much more important use case. Okay, and um, for example, let's say that you know mm, the weather forecasting one, it's forecasting in, I think it started forecasting in 1950, right? So it's pretty much helpful us to have a weather forecasting. Okay, so key benefits are there, for the banking sector, with the forecasting will kind of price product based on weather risk. Then shipping, these are the key benefits for each and every industry by these weather forecasting implementations. Okay, so then give me a minute, I need to drink some water. Yeah. So the other use case is urban planning, right? So this is a kind of a use case, kind of a fascinating use case from Sri Lanka. And what research did is researchers use cell data records, right? CDR records from mobile phones and then mobile phone towers, and understand how people moving through Colombo throughout the day. Okay, so in this case, I think there's a link as well. You can just go to link and see what's the internal details are there. So then at noon, actually, you can see that the high density town in the commercial areas, right? So then at the midnight, people have, you know, dispersed in the residential areas, right? So these kind of factors that data enables to, kind of have, um, kind of have, okay, wait a minute. Okay, kind of have to have new projects like kind of smart city applications, the public transport routes, then based on the moving patterns, right, of the people, then scheduling waste collections, likewise, right? So this is a kind of a traffic system. This can be used for the kind of traffic system as well. So that means when we track the you know um, this mobile transportation routes, so then we can get idea how people moving in the midtime and daytime. Then we can have solution easily for a kind of a exact place to solve that kind of problems like traffic stuff. Okay, so then I added another example, a log data set, right? So this is a kind of sample from the NASA actually. So it's a publicly available actually, and you can see a IP address there. Then HTTP method is a get method, then method and path, right? The status code and response size, all the stuff are in here, right? So what you can extract is actually you can extract users behavior and which pages are most popular, and then traffic analysis, the peak hours, seasonal trends, and geographical distributions, right? So where it coming from the IP address, and error analysis, what pages are broke, kind of stuff. We can get a data set from here. Okay, so this is a kind of a real data set. You can, I think it's in the Kaggle as well. So then let's move to the kind of important part, the big data system architecture, right? This is a kind of architectural thing. So there are some layers, okay, in the big data system. So this is a kind of overview slide. So we have data sources layer, acquisition layer, storage layer, then processing layer, and analytics layer, right? So every big data system, you know, regardless of this specific tool it uses, it follows the fundamental architecture, right? This is a kind of these things as a kind of a blueprint, and you will use every system we design on this, right? Data sources, acquisition, storage, and processing, right? So let's deep dive into kind of these layers one by one. So first layer is a kind of data sources, right? So function is generating raw data. Example is kind of application sensors, database APIs, and the output if of that one is kind of raw events, right? File stream likewise. Acquisition layer is capture and buffer. This acquisition layer, the capture and buffer incoming data, right? So example tools are, like I said, Apache Kafka and Flume, something like that, right? So the output should be of this layer is kind of ordered and durable event streams. Okay. So next layer is kind of a storage layer. So it's a persist data reliably at ASK, right? Kind of SDFS, Amazon S3, Azure Blob, Cassandra, then MongoDB, right? So it's start data blocks or kind of objects, right? This is storage layer. So then if you are dealing with the processing layer, so it's a transform and analyze data layer, right? So then a kind of example tools are Apache Spark, Flink, then MapReduce, Hive, something like that, right? So start in here actually we are focusing on the structured result and aggregations. Okay. So then finally is the analytical layer. So kind of having dashboard, right? The Power BI dashboard, it's in this layer. Okay, so let's move to the acquisition layer. The acquisition layer means actually uh it's a kind of a front door to your system, right? So accession layer is where data enters your system, right? So it must handle simultaneous data sources um, APIs, IoT, things like that. But it should as absorb the traffic spikes, and we cannot drop in any records in the accession layer, right? Because every record is valuable, and we need to deliver that reliability to the storage layer. Even let's see that this storage is too slow or something like that, but if it's too slow kind of stuff there, but we need to somehow deliver data reliably. Okay, so for example, let's say that think that in a post office stuff, right? It receiving mail from thousands of senders simultaneously. Okay, so what will happen is the post office does not process each letter immediately. Okay, you know that process, right? If post office receiving a mail from kind of sources, it does not does not process each letter immediately. So what they will do it queues and deliver them order. Okay, so that means it queues in a queue and deliver in order. Okay, so the acquisition layer is the same way, right? So these are the one of main acquisition tool that I'm going to talk with. Apache Kafka. It's a kind of a distributed, let's say, a fault tolerant event streaming platform, right? So it works like a kind of a distribute message queue, and there are two the pub sub modeling, right? So producers can write event into topics, and consumers can read topic events from that topic, right? So it can handle actually millions of events, and basically it can retain the data for days or week or something like that, right? So that means, let's say the consumer is crashes, it can restart and reply the events. Okay, so then that's why it's durable and act as a kind of a message key. So Apache Kafka, I will have another um, session on Apache Kafka, and I will show in practically how it work. Okay, so there are a lot of Kafka in production, right? So in kind of Airbnb, I think those are the kind of products that they use Kafka, right? Lot of uh, products use that one. So the final one is not a final one, right? So it's a storage layer. So you know, let's think about like this, right? So there are five requirements to be the biggest big data storage, right? So not every storage system qualifies as a big data storage. So it must it must meet kind of five specific scenarios, right? So because the thing is, it needs to handle petabyte scale works. Okay, so 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 the following factors need to be as a key requirement. So first thing is scalable, right? So that means must handle petabyte of across the nodes. Okay, so there are nodes, so you need to handle a petabyte of data, right? So adding a new node should be not be kind of increase capacity linearly without, you know, redistribution from the sketch, right? That mean I think if you add a new node of data, then it should increase. Yes, that's okay, but you don't want to be the redistribution from the scratch, right? That's called scalable. Then the fault tolerance, that means the the thing is actually it must survive individual machine failure without a losing of data. Actually, the SDFS archive this one, and as I said earlier, also it store three copies of data block in different machine by default, right? So that's help us to, survive on machine failures, right? That's called fault tolerance. The other one is secure, so that means protect data through encryption and rest and transit, right? So, okay, there are a couple of things that we need to protect data through encryption, right? So one thing is data transit. So we need to do transit using a kind of a encryption way and role-based access control, right? And okay, role-based access control and kind of audit login for the data, right? So the other one is high performant one, right? So that means must support parallel reads from across many nodes simultaneously. So that means, for example, is Spark job, right? So it should read from HDFS and can read data from all node at the same time. So that's why we need to say it's kind of parallel reads, right? That's to be kind of highly performant one. Then highly available one. So that means must we need provide consistent access to 4 into 7, right? So So it's a if there is a plan maintained, so unplanned failure or rolling update must not cause a downtime, right? So the SL the service level agreement should be kind of 99.9 something like that. So these are some storage options, right? So HDFS type is kind of a distributed file system. It's best for batch processing and workloads have Hadoop ecosystem, right? So then Amazon S3, it's a kind of object storage, and Azure Blob also it's also object storage, and then other thing is Apache HBase, right? NoSQL, no, it's a kind type is kind of I think column family one. So then it's best for randomly read write access for large data sets, right? So then the other thing is kind of Cassandra, right? So it's also kind of a NoSQL white column store, and it should also best for high rate of throughput writing and distributed globally, right? So those are some storage options for each scenarios, and yeah. So the other thing is actually um, okay. These are the some storage comparisons, right? So that I tell you already. So small data, um, you know, mm, unstructured, structured, and distributed file system or SQL. So this is kind of a small data is scale. Let's say small data. It's good for unstructured file system, and structured is database, right? So small data is kind of traditional storage system, and medium data it can be used to have hybrid approaches, right? So then big data, this is the deal what we are talking about. Distant systems are necessary. So we talk about what's distributed and how it value for the big data industry. And yeah, so choice actually depends on the data type, the access pattern, and the scale and consistency, right? So these are the some facts that you need to know about the storage system comparisons, right? Okay, so let's move to the other one. This is the processing layer, right? We are talking about the processing layer. So we talk about storage layer earlier, then now processing layer, right? So okay, so processing layer there are three process paradigms, right? One is batch processing, stream processing, and interactive queries. Okay, so actually the processing paradigm that you choose is determine how quickly you need to use case to needs an answer, right? Actually it depends on the use case, and there is no kind of what's the best paradigm or something like that. So only thing is we need to design the right one for a given problem, right? So if you are talking about that processing, the processing time can be hours to days, and tools is kind of, and is I told you earlier, it's a MapReduce, Apache Spark, right? Then use case example are kind of daily say sales report, machine learning model training, and ETL, something like that. Okay. So then other thing is streaming processing, right? Streaming processing means milliseconds to minute kind of processing time, right? So tools are kind of Apache Flink and Kafka Stream, the CD. Those are the tools, right? So use case example can be kind of the fraud detection, right? The credit card fraud detection, right? The, then live dashboards and real time recommendations, and those are the stuff for the streaming processing. Okay, so third one is kind of interactive queries, right? The fast queries for exploration, kind of Apache SQL, so something like that, right? So those are the use case examples and the processing layer, the processing paradigms that we need to know for processing layer. Okay, and okay, so if we move to the next slide, this is batch analysis. Okay, so okay, I know that So are you feeling kind of boring stuff? Hello guys. Can you talk with me? Hello?
Yes, sir.
Uh, yeah, I think yeah. The reason is actually you will feel kind of a boring stuff, right? So these are kind of theoretical stuff. And you must understand first why the big data infrastructure why the big data infrastructure is kind of needed, and why we need to do this these things, and why we need to choose these technologies and stuff, right? So the goal behind this lecture is actually I need to give the from the scratch, I need to give the knowledge to you to understand the concept deeply. Okay, I know you are using that AI tools for coding and stuff, right? But I experience when you're going for interview kind of stuff. Now, the learning patterns also kind of a little bit changed, right? Not little bit. It's most of the things are changed, right? Because of the AI. So in earlier, we use kind of a Google it, right? We are using Stack Overflow, and if we are getting kind of a problem, we are reaching step by step. Okay, so first we are try to Google it, right? Then okay, we are mostly I prefer to use actually I used Stack Overflow, and in that time if you have a kind of a bug in a code something like that, I just okay, read line by line, and I try to understand what's the concept behind this one. For example, let's say there's a kind of a keyword in the code, or I usually do in .NET and C Sharp. So for example, if there any kind of a keyword asynchronous or something like that, so then what I did is I just refer the example and stuff in the kind of more web pages, kind of Stack Overflow, then kind of let's say Google uh, Greek for something like that. There are some website that it helps me to find out the exact what's happening, right? Right now what happening is you guys go to ChatGPT and put the code in there, then you just ask, okay, there's a bug issue, can you just solve it, right? Normally I know that you are also doing that one, that's okay. But if you are going to a kind of industrial level interview or something like that, they are expecting kind of a um, concept knowledge from you. Okay, because they know that you are already used chat gpt and AI stuff to complete this course, or anything else. Okay, so that's I think I try to explain this slide with a kind of examples, so you can re-listen using the this recording, and try to get a idea what I'm going to do in this course. And end of this course actually, you will be have to have a kind of a good knowledge on infrastructure tools and stuff, right? So I am not expecting kind of a to do the final exam and then not like that. Okay, that's normally you are, I know that you are complete those things. In that days also I also did same thing. Okay, I'm focusing on the final exam. Okay, I just uh, review the what is lecture notes, and then I just it, and then right after that one I move to the other lecture, right? Not like that. So that's why I feel that there's a kind of a industrial gap. um, you must work hard for to fill out that gap. Okay, so you must getting into knowledge of the extra knowledge, and that means you must know what are the new technologies that coming up for a kind of a big data infrastructure or cloud stuff. That's why I recommend you to do the cloud certification, right? So what I did is actually it's kind of a hard thing. So I just wake up at the early in the morning, kind of 4 p.m. or 4 a.m. something like that. So because I am working in a kind of a night all day, right? For example, I'm working in a kind of a foreign company. So then usually I start my day in a kind of 12 p.m., right? Then I stop it my day actually at 1 a.m. the other day. Okay, 13-14 hours. So that's a normal industrial thing, right? But you need to put some effort to minimize the learning curve of the technologies. Okay, what I did is I just there are some courses in the Udemy. Okay, you can buy it at the discount level, kind of $6 or $7. You can buy some courses related to cloud certifications. Okay, so if you are willing to do AWS, there are some AWS intro course certification for you, and I don't know whether if you can do it. That's okay. You must pay it for kind of $80. So if you are working in a company, they will reimburse you. But if not, you have to pay it, right? So what I am telling it, at least you can go to the Udemy, then try to find the courses. I used to find the Azure courses, and the course content creator's name is kind of Alan Rodriguez or something like that. So you can go to the Udemy and find the course contents there. Then there are some certificate number, kind of A is it 900, A is it means Azure 900, A is it 2, 2 Note 1, kind of DevOps certifications, right? Likewise, certification numbers are there. So you must find it by number. Then you must pay for that course. It's kind of $7. I think 20,000, sorry, 2,000 or 3,000 will cost for you. Then buy it, right? Then try to watch it. Okay, then that's a kind of a not knowledge from the your coursework, but you need some extra knowledge. So then you are be a kind of a valuable person to a company, right? So then they will hire you at a um, competitive salary. Okay, so that's why I looking forward to meet you at a kind of at least at the last lecture. I want to have a kind of a industrial knowledge, so that's why I invited a kind of a guest speaker as well to share the knowledge of him as well. So yeah, let's see how it's try to do the. I will try my best to give the knowledge what I have, and yeah, let's try to finish this um in a good way. Okay, so now back to lectures, right? um this is budget analytics, right? So the bread processing, it has been workhorse of data analysis for decades, right? So I think the tools have evolved dramatically, and the fundamental but the fundamental concepts are unchanged, right? So read a large data set, process every record, write results. So those are the stuff, right? So in 19 this is the evolution of batch processing framework, right? In 1990s, it uses shared memory. So scale is kind of 4 or 2 to 16 kind of single machine CPUs, and key limitation is kind of a it's basically ceiling on CPU and run per machine. And later on 2000s, we are using message passing interfaces, and it scaled up to 100 machines, and fast internet is there. So then complex programming model, but expensive in hardware because we are using hundreds of machines, right? But in 2000 kind of 10, so 2006, 12, 14 kind of a day. So we are introduced Apache Hadoop, MapReduce, and Apache Spark, right? So it scale thousands of community machines and same community hardware as a Hadoop kind of stuff. And Apache Hadoop is kind of a thing that the disk IO between there's a disk IO between every job step, right? It's a kind of a slow process, but when it comes to Apache Spark, it use kind of a in-memory stuff, right? So then that's why it's 30% faster than the MapReduce, and I'll try to complete both Hadoop and Apache Spark as well, right? So in later on, actually, right after 2020, though there are also the AWS, EMR, Dataproc, something like the cloud cost management, and that's the kind of cloud-based products are coming up, right? That's the kind of the batch operation evaluation of the batch processing frameworks, right? So command back operation you will implement is kind of a mix in aggregation, right? So what? So sum, count, average, mix, max, something like that, right? So then you can join combine two large set using a kind of a command key. Okay. Then filtrations, right? Then that means removing records which do not meet criteria, right? So then sorting and ranking. Okay, so finding the top um, in items of the large data set, something like that, right? Then machine learning model trainings. Okay, so then training a regression or classification model on a full data set, something like that, right? So those are the some common batch analysis of operations. Okay, then okay, this is the kind of a tool history. So what I explain in here as well is a kind of a uh, try to explain it clearly in here. So we have SQLite queries, right? So the reason is behind this one is now think about in 2010, I think Hadoop is a powerful tool, right? So as I said, it's use disk IO operation and it's Hadoop is a powerful tool, but it requires kind of a programming stuff, right? Kind of Java, right? So then let's say if you are kind of a business analytics or data scientist or kind of an engineer, you should know about the programming languages, right? So that things kind of a another learning curve for a kind of a data scientist and stuff, right? So what the reason behind this one is the data community recognize this as a kind of a um, SQL actually the data community they recognize as a kind of a known by millions of professional, right? So what they did is they created kind of a family of SQL top of the Hadoop tool, right? So now Hive QA, okay, you can see there's a Hive QL. Under this one, the Hadoop is running, right? But the thing is, you don't need the kind of programming knowledge. You want to know kind of a simple query thing, right? So that's what happened inside the Apache and Hive QA stuff. So in this case, you can see the insert override table speed and select our average as average V and bus ID from the bus time and group by bus ID and get hours, right? This is a simple query, right? Behind the scenes, how you translate this one into kind of map reduce jobs, then map it how it map it by bus ID and hour, right? This is the mapping part. Sorry, this our yeah the speed one, right? So the mapping parts is actually it's bus ID and hour and for its each reading the reducing part. Okay, reducing part is group by ID and hour. So this is the group by ID and hour, the reducing parts, and finally it calculates the average bus speed, right? This is a kind of a stuff in earlier you want to know about the Java languages because you need to write kind of programming behind the map reduce. But in here, what happened is you don't want to know about the Java. You only need to know about the SQL. Uh, because of its top of the map reduce one, it's a high QA, right? So that's the thing that they use to know about the you know what that the the big data community recognize that's a kind of millions of professionals can use this high QA, right? So yeah. So for example, if we are using HiQ, Apache Hive, it's top of the MapReduce, right? And if you are using Spark SQL, sorry, SQL, then it's fast and in memory. Because of that one, it's 30 times faster than Apache. Hive, and then there's a kind of another technology called Presto that we are not going to deal with this one. We will deal with the Apache Hive and Spark, right? So actually, there's a key insight in this one. That means the SQL makes a big data accessible to analysis for scientists and engineers who are not professional with the distributed system experts, right? So they this actually this one demonstrate to access of big data, and one of the most important field in the big data in the industry, right after the right making kind of queries on top of the Hadoop stuff, right? So yeah, these are the some key value insight, uh, you know, how it use value insight for the degrade fast, right? So domains where the speed is critical, right? The stock markets, microseconds, I think it needs then traffic systems, the surveillance, and the patient monitoring. So like stuff you need that, right? So this is the kind of okay. We have completed Hive and Spark QL, then value. So these are kind of simple things. You can just read it, right? I will send this lecture note for you. And let's move to the real time analysis. Okay, so okay, this is the deal. Actually, I tell this in the kind of hours ago as well. So for many modern business problem, so let's say the result is 1 hour old or 1 minute old. Sometime it's 1 second also. Okay, it's completely useless, right? Okay, the simple example, the hospital example, when patient's blood pressure drops dangerously, doctor needs to be an alert in a quickly in seconds, right? What happen if it's in hours? It's too dangerous, right? So example, kind of fraud detection, credit card, right? Bank needs to be blocked in a kind of a millisecond, right? So it's not should happen right after the daily batch run, right? So this gap is filtered out from this streaming processing, right? That's why real streaming processing architecture in here, the sources processing and sinks, right? So the streaming processing architecture, the sources one. So the sources means where event uh, come from, right? Like Apache Kafka topics, HTTP endpoints, then CDC, change data capture. I'll explain in the CDC in the yeah, it's data warehouse lecture. I think we need to do CDC and the IoT sensors, right? Then stream processing means actually, applies a logic to the every event, right? So, for example, only keep events for kind of a matching a condition, right? So, let's say that we can aggregate it, right? So then by that we can, uh, we can use that data for kind of detect patterns that like alert when sequence of event when machine knows a pattern, right? That means kind of security alerts. um if we have a kind of a, let's say, um not from that means risk data. If system detect a risk data, then it will send us an alert, right? So likewise, that's why we need to apply logic on every event, and then it should be calculated within a kind of microseconds, right? The, um, the other one is since the result where the result should go. Okay, that means the real time dashboard, right? So that as I said, the top management can get the business decision using the real time dashboard, right? If it's for example stock exchange, right? So people who are try to investigate, try to do investment in the stock market. So it's pretty much used for them to have the kind of data within kind of a seconds or minute, right? So yeah, those are the kind of real time analysis. and why we need that one, and this is a kind of architecture. And yeah, so we are moving into final session, final slide of the lectures for today. So these are the some two use cases, right? So if I go to some cases, so this is a kind of a real world example for streaming processing. So I think you know about the Bluetooth, right? So it's BLE, right? Bluetooth Low Energy. So imagine you are inside a shopping mall, okay, and your phone Bluetooth is turned on, right? So around the shopping mall, there are some small devices called maybe BLE receivers, okay. So what happen is these receivers pick up signal from your phone, and as you move, right? So if you go to other place, it will pick up the signal, right? Now what system will do is it collect all the signal as events, right? So it's not wireless signals, it's Bluetooth signal, right? That means they are not always receiving in a correct order, right? So first system will do it this phase, right? It will fix the order of these events, okay. Okay, think about that. You are in a mall, shopping mall, then you have a mobile phone that's turned on a Bluetooth. Then in the shopping malls, they set up small devices to collect Bluetooth low energy receivers, right? Then what receivers will do it? It will pick up signal from your phone as you move it. Then what system will do it? It will order the events because it's not arrive in the correct order, right? Now next thing is it calculates your position, right? This is called triangulation. So it does using this signal from multiple receivers, and it combine and then kind of do a process and eliminate where you are. Okay, this is called triangulation, right? Now right after that one, system will actually smooth your movements, okay, using something called Kalman filter, right? It's in simple term, it removes the noise data and make your path look more natural instead of jumpy, right? So then now, for example, let's say that you are suppose many people actually stop in front of a one shop, okay, and for a long time, but the system detects this, tells us that okay, there are a lot of people inside your shop, but they are not coming in, right? So system can detect this one and tell to the mall for this shop, make it kind of attractive way, right? So then definitely we will go for shop, right? So actually, honestly, I will tell you kind of example, right? When my wife actually working near the kind of um, Ispasilon, I think you heard about this sometime. So she always you often to go inside, and sometimes she buys something, but sometimes not, right? Because it's kind of attractive way. In Candy, it's a kind of attractive shop is there, right? Ispasilon. There's I think the kind of the BG kind of stuff, right? I don't have a kind of idea. So she used often to use go to that shop for shopping, right? Because it's in an attractive way. Same thing here. If the sensors detect something, many people stop in front of a shop for a long time, and if they are not coming in, so it system detect this one and tell that to make it kind of attractive way, okay. So then kind of airport also we can use this one. Many people is stuck near the security, and system can alert to staff, okay. So open more counters, something like that, right? This is a one kind of real time scenario in the BLE. Okay, so then other use case is kind of a SOCA analysis, right? So in this I don't have idea, but much more I'm not a good fan of soccer, right? So I use this one as a kind of a these are kind of famous example for real time, right? So in modern soccer, actually huge amount of data is kind of collecting the match, right? So data is coming from various kind of sources, right? For example, sometimes players wear sensors to track their movement, right? And then track their speed and acceleration, right? At the same time, the cameras and the ball tracking system also monitor the position and movement of the ball. Okay. In addition to that, there are some environmental sensors and measure the condition like temperature and humidity, right? So a lot of data coming from multiple sources. Okay. So now what happened? So then it's if it's processed in a real time using advanced analytical system, so uh, the system can maybe calculate the importance of the metrics such as how much the distance of each player covered, then how long player holds the position of the ball, and how team should be positioned in the field. So this kind of stuff, if we can have a kind of a good advanced analytical system for processing real-time data, that will be very helpful for the team, right? So for example, let's say that we can get valuable insights as well, right? Kind of if we can detect a kind of injury for a person and identify if there any unusual movement, then it will be good to detect it, right? Then the other thing is, if it can have live dashboard for coaches and the kind of broadcasters and something like that, so then they're showing real-time performance statistics, right? So these are the kind of thing that we can have advantages of the real-time computations. Okay, so this is what I explain in here. And this is the thing, so you can watch the YouTube video, and so in there you can get a clear idea how it supposed to have a real-time computations. Now, okay, this is a kind of another stuff. It's, the parallel and distributed computing, right? Actually, these two terms, okay, so it's oftenly interchangeably kind of stuff, but they describe fundamental different architectures with the different characteristic, right? Trade-off, limitation and stuff, right? So let's say something like this, right? A kind of a, so you can read this one as well, right? It's clearly I mentioned in here what are the characteristics for the parallel computing and what are the characteristics for the distributed computing, right? So then for example, multiple processors on same machine, but multiple machines are network connected, right? This is distributed computing. And for parallel computing, you use shared memory, fast access, but this has your own access. Like this is tightly coupled because we are using kind of a one shared memory and stuff. And this is kind of a loosely coupled, right? This is complex synchronization, but this is complex synchronization. This is easy for synchronization. So those are the advantages and stuff are there. Then um, yeah, so these are the key limitations, limited by a single machine, and this limitation is slow and complex, right? So these are kind of sound knowledge about the parallel and distributed computing. So there are kind of 42 slides are there. So I don't know whether so is it okay to do this like this, or do you want me to kind of explain it slower? Can I have some feedbacks from you guys? I really appreciate that one. Hello guys, you can talk actually. Yes, yeah. Can I have some feedback? Actually, it's not a kind of a deal. So is it okay to tell you continue like this? So is it, am I doing kind of a speed, or do you want me to explain more or something like that? Pubudu or Nadisha?
Yes, sir. I think this like this lecturing is okay.
Okay, okay. So if you have any question, please put it in the chat, right? So then the basically, as earlier also I said, I like to do it in a physically, so then we can have kind of a interact closely, right? So then I can tell it kind of a example, so I can discuss. Yeah, but there are limitations of the online lectures, right? So yeah, okay. This is the end of the lecture, and these are the key summaries, right? That we have discussed, and so we covered actually the big data requires fundamentally different infrastructure than traditional databases, right? So it provide the computation environment, and big data is a kind of a road, right? And so big data programming is used that environment to produce is a kind of driving, right? You need both actually. So then we talk about the network bandwidth, processing power. So these are kind of really three bottlenecks, right? Every architectural design decision on the big data is about you know working around one or more these three constraints, right? What are those? Storage, network, and that processing power, right? So other one is distributed processing, right? It's a kind of a fundamental solution, more move to computation to data and processing parallel and kind of stuff, right? So then for the architecture, complete architecture has 5 layers: acquisition, storage, processing, analytics, and serving, right? So far like that. Then we are talking about the three, you know, processing paradigms, right? Like what batch processing, stream processing, and interactive, something like that, right? So those are the actually we talk about the real world application of this soccer, then the Bluetooth, low energy, and stuff, right? So yeah, please listen the lecture again and try to get the idea. So actually this combined all the cost containing here. So that's why it's kind of a have a kind of a concept. I need to tell the concept, and so there is a kind of a roadmap for the course as well. So actually I'll try to do HDFS, the Hadoop file distributor file system, then NoSQL database. Next week, maybe I will cover NoSQL databases. Okay. So then actually that's the storage layer, right? So HDFS and NoSQL databases. Then MapReduce, it's another lecture based on processing layer in Apache Hive, right? SQL on Hadoop. What I tell you, right? So why we need kind of a SQL on top of the Hadoop, because the data scientists, they are not expert in programming or something like that. So it's pretty much easy for them to query based on the Apache Hadoop, right? Then I will try kind of a deployment pattern, right? So that means Kafka and Lambda architectures. Then you will understand about the concepts and that some kind of a practical knowledge related to data warehousing. That that's a classical way, right? So ETL, right? Extract, transform, and load, right? Not ELD. Okay. So then I try to do a kind of a session related to Apache Kafka, right? So all the things I try to using Docker desktop. So in my local machine, there are some images for the Kafka. Then I can run it there. So I'll share all the scripts and code with you. So no doubt, no, don't keep doubt about that one. I'll share all the details with you. And then the SDFS Hadoop also I try to do in my local machine, and so then you can try it out, right? So in the final day, you will have a kind of a physical session on the kind of modern stack, right? Kind of data lake and Apache, Spark, and stuff, right? So let's hope that we can have that day at least. And so just keep remember on the group assignment. So you will get 20% for the group assignment. So I'll ask your tutor to share kind of a Google sheet that has group number, then five students for each group, then student number and name. So then you should group kind of with a kind of a five students. Then I will assign a paper before 2 weeks, right? So, for example, let's say I'm not telling that I will start it from group one. So you form a group, then I will assign it randomly, right? It's not telling that group one will present in the first day. Okay, I will. So basically, those I will give explanation on the research papers in next week because these research papers make world difference, right? World into actually it, push the world into next level, right? For example, finding the Hadoop, right? So there's a research paper on that one, which changed the big data industry. So what you can do is you have to create slides, then present to the um, you know um, all class, and every student will get 5 minutes. Then altogether, if we have five students, then it will have 25 minutes. Then 5 minutes for question and answers, right? So everyone in the class can ask questions, right? So I hope that there will be. Right now it's 12. I think before the inter it's 20, right? No worries, but tell others to join as well. That's okay. And then so I think we will have. I expected that we will have kind of 25 students at least. So because the registration is not over, and yeah, that's the plan of to do complete this course. So keep in mind that in 11th of April, I think, let me check it again. Uh, where's my phone? Okay, let's check in again. Uh, okay, so in the 4th of April, we have class, but we will not have in 11th of April because of the new year. Then 18th is the day that we are starting the group presentation, right? So actually, at the end of the lecture, let's start that one. It will take around 30 minutes, right? So then for the one, yeah. So I will publish the paper for a particular group at 4th of April. Then they will get 2 weeks, right? Then at the 11th of the day, actually, I will publish the group for the 25th presentation, right? Then they will also get 2 weeks, right? So then, like that, I will publish for each and every paper for each and every group. Then we will have classes in 4th of April, 18th, 25th also we can have it. No classes in 11th. Then no classes in May 2nd as well, right? It's a kind of a visa day, something like that. So we will have in 9, 16, 23, 30 of the May as well. So then, yeah, so then we can have a kind of session in 6th of June or 13th of June, right? So then let's try to finish the course content as well. Yeah, that's my plan. And any questions, guys? Okay, speedos. Okay, and Hello, guys.
Uh, so,
Okay. Um, yeah, this one is correct. So basically, I do like this one, the front end one. You know, do you want kind of a Kubernetes one as well? Actually, this is not a kind of a session. I think if you have time, I will give some ideas. Eh? Did you do Kubernetes actually? Okay, okay. So, yeah, can be extra lecture, right? So it's I cannot complete within a kind of 4 hour, but I try to give it right. So because the reason is you need to know that one. Sometimes the industry expected, right? So if you are thinking like this, right? Okay. So yeah, something like this. So if you are you using LinkedIn actually? Do you guys have LinkedIn profiles? Okay.
yes,
So yeah. So now just search the job post. Okay. Just search the job post, and in that things you can find what are the requirements that you need to fulfill for that job. Okay. Then try to complete that technologies from your side. Right. So that's the deal that how you need to eh, deal it. Right. And yeah, so that's the end of the lecture. And uh, yeah, if there are any questions, I can please. Do you have my mobile number? No, right? So I. Uh, so this is my mobile number. Sorry, it's a direct message, right? Sorry. Uh, okay. This is my mobile number, and if you have any questions, ping a message, a WhatsApp message, and tell you that you are a student of uh, this course, right? Then I can clearly identify who you are. Uh, okay, that's the end for today's session. Anything else, guys?
no, no, sir.
Okay, so mm, 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 right. Uh, yeah, yes. Okay, I just went through the chat actually. So Rashmika, I misunderstand your question, right? Sorry for that one. So you're asking about the spin up database instances, right?
Yes,
Is
sir.
that correct? Okay. So I think I thought that the instances in the backend instance something like yes, you can do it. You can add vertical scaling, right? Because it has 8 GB RAM to 65 something like that, but it will cost you something like that, right? So the horizontal scaling also there. You can add database servers and split the database um, in many machines, right? So actually in cloud stuff, it's automatically do that one, right? So the reading from the replicas and stuff. Uh, yeah.
So I just asked that question because the databases,
Rashmika, right? You are
yeah,
sorry. Okay.
the databases are stateful. So
Mm.
while we spin up a instance, so the state can be changed in there. It is something exceptional case than the backend because they are stateless. So that's why I asked that question.
Yes, you are correct, right? So actually, it's stainless because you must keep the data safe, right? So it cannot be lost, right? So then other thing is it must be stay consistent, right? That means in the multiple nodes you can have it. Okay. So then yes, you are correct. It cannot just add servers easily. So unless there are some systems like so then statelets means it's easy for scaling now. So but we need to sync data, right? So that's why uh, you know the kind of okay. Here's the thing, right? In Kubernetes stuff, there are some pods that can spin up the databases. Okay, so in that case, we need to deal with that one. Okay, but if you are moving in the kind of a cloud project, it's automatically dealing with that, right? So that's the thing actually. I think you are expecting, right? So is that the question that you got the answer?
Yes, sir. Thank you for.
Okay. So mm, okay, that's the deal, and let's wrap up the today's session, right? Next time I prefer to do with the NoSQL databases and stuff. Okay. Okay. See you guys in next lecture. And thank you for participating.
Thank you, sir.
Okay. Thank you.